Hello friends, myself Rajendra Mahajan presenting my video on Karl Pearson's coefficient of skewness. Let us solve the problem. Find Karl Pearson's coefficient of skewness for the given data. Data containing class and frequencies. Class 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79 and last 80 to 89, and the corresponding frequencies are 5, 9, 14, 20, 25, 15, 8 and 4. If you see the values for the class, it is exclusive. First of all, we have to convert it into inclusive, and then to find Karl Pearson's coefficient of skewness, formula is Jp is equals to mean minus mode divided by standard deviation. Means we require to find mean, mode and standard deviation, these three quantities, where mean is given by a plus summation of fi ui divided by summation of fi into h. Mode is equals to L, lower limit of that model class, plus fm minus f1 divided by 2fm minus f1 minus f2 into h, and standard deviation is equals to square root of fi ui square divided by summation of fi minus in bracket summation of fi ui divided by summation of fi bracket raised to 2 and into h. These three values we have to make a table as shown. Class, then new class we have to perform, then midpoint x, corresponding frequencies f ui, fi ui and fi ui square. All these columns 1, 2, 3, 4, 5, 6, 7 columns we have to make. In the first column I will substitute the original values of class 10 to 19, 20 to 29, 30 to 39 up to last 80 to 89. And then a new class, take a difference of this 20 minus 19, we get 1 divided by 2, that value is 0.5. Therefore subtract that 0.5 from the lower limit of all the classes and add 0.5 to upper limit. Also 9.52, adding 0.5 to this 19, we get 19.5. Therefore this is the new class instead of the 10 to 19. Then next is 19.5 to 29.5, 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5, 59.5 to 69.5, 69.5 to 79.5 and 79.5 to 89.5. This become inclusive. And then the midpoint of this all classes. Therefore midpoint of the first class, take the average value of this. Therefore average value is 14.5, and as there is a difference of 10, increase it by 10, we get next one as 24.5, 34.5, 44.5, 54.5, 64.5, 74.5, 84.5, and the corresponding frequencies we write down. For the first class it is 5, then 9, then 14, 20, 25, 15, 8, 4, and then take a sum of all these frequencies. If we add all these values of f, we get that summation as 100. Therefore sum of fi is 100. Then see the maximum frequency. Here the maximum frequency is 25. Corresponding midpoint is 54.5 and the corresponding class is 49.5 to 59.5. Then we find out ui. What is the formula for ui? xi minus a upon h. It is, I will write down here, xi minus e divided by h. Assume we consider as 54.5. Therefore, 54.5 minus 54.5 divided by 10, we get that value as 0. And then directly we write down for upper side as minus 1, minus 2, minus 3, minus 4, and lower side as 1, 2, 3. You can cross check it by performing the calculation as xi minus a upon h for all the remaining classes. Then a product of f into u, therefore 5 into minus 4, we get that value as minus 20. 9 3s are 27 with minus sign. 14 into minus 2, minus 28, minus 20. Next one is 0. 15 into 1, we get 15. 8 to the 16. And 4 3s are take a sum of all this. 15 plus 16 plus 12 minus 20 minus 28 minus 27 and minus 20. That sum is, if we perform by calculator, we get that value as minus 52. Check it, cross check it. And then last column, f into u square. Therefore, minus 4 square is 16. 16 5s are, we get 80. Minus 3 square is 9. 9 into 9, we get 81. Then minus 2 square is 4. 4 into 14, we get 56. Then minus 1 square is 1. 1 into 20, we get 20. Then next 0. 1 square is 1 into 15, we get 15. 2 square 4. 4 into 8, we get 32. 3 square 9, and into 4. 9 4s are 36. Then take the addition of all this. 80 plus 81 plus 56 plus 20 plus 15 plus 32 plus 36. By calculator, we get that sum as 320. Here the table is completed. And then using this table values from the table, we perform the calculation for mean, mode and standard deviation. Formula for mean is already I have written a plus summation of fi ui by summation of fi into h. The value of a is 54.5. Summation of fi ui is minus 52 divided by sum of fi is 100 and into h 10. Simplifying it further, we get that value as 54.5 minus 5.2 and nothing but the value of mean is 49.3. This is the mean of that data. We find formula for mode is L, lower limit of model class, Fm minus F1 divided by 2Fm minus F1 minus F2 into H. Therefore, here the maximum frequency Fm is 25. Model class is 49.5 to 59.5. Corresponding classes. F1 frequency of the preceding class, that frequency from the table, it is 20. F2 frequency of the succeeding class, it is 15 and H 10. Therefore, substituting all these values, we get mode is equals to, I will substitute the value of L as 49.5. Maximum frequency is here 25. F1 20. 2 into FM 2 into 25. F1 20 minus F2 15 and into H 10. Simplifying this calculation, we get 49.5 plus 25 minus 20, we get 5. 50 minus 35, we get that value as 15 and into 10. Performing this calculation by calculator, that is 49.5 plus 50 divided by 15, we are getting that value as 52.83. as the value of mode. Second value, required second value, and then we go for calculation of standard deviation. It is square root of summation of Fi ui square. Summation of Fi ui square from the table, that value is 320. See the table. Summation of Fi is 100. Sum of Fi ui minus 52 divided by 100 and its square and into 10. It is square root of 32 by 100, we get that value as 3.2 minus 52 by 100 and its square, we get that value as 0.2704 into 10. Nothing but square root of 2.93 into 10. If we take the square root of 2.93 and multiply it by 10, we get that value as 17.11. Checked by calcing. Therefore, this is the standard deviation. Then, after getting all these three values, we substitute in that formula of Karl Pearson's coefficient of skewness. I will write down that formula once again. Karl Pearson's coefficient generally we denote by Jp, mean minus mode, divided by standard deviation sigma. The value of mean is 49.3 minus mode is 52.83 and divided by standard deviation 17.11. We get that value as minus 0.20, and that value must lie between minus 3 to plus 3. Here that value is in that range, and therefore whatever the value we have is the correct one. The Karl Pearson's coefficient of skewness for that given data is minus 0.20 as the required answer. In my next video, I will discuss one more problem of moments about mean or moment about a point. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.